All right, so we got f of x equals x to the nth, and we want to know what that is going to be as far as the derivative is concerned. So this is going to be, we're still doing derivatives. Yeah. So f prime of x is equal to the limit as h approaches 0 of what is f of x plus h. What's going to be x plus h raised to the nth power minus f of x over h. All right, good. Say that again.
Where'd the end go for the second part? Why is it just f of x and not f of x to the end? Oh, okay.
There we go. Now we're good, right? Okay. So, I mean, it technically wasn't incorrect, but it definitely was not written the best way we should have. So let's just look at Pascal's triangle real quick and see what's happening with it. We got 1, we got 1, 1, we got 1, 2, 1, we got 1, 3, 3, 1, we have 1, 4, 6, 4, 1, we have 1, 5. I lied to y'all, I am going to go to the 15th. All right, I'm going to stop there. All right. There's some patterns that exist here, and I needed to carry it out that far to let us see all the patterns that are happening. All right. All right. Now, let's think about what the leading coefficient is. The leading coefficient, again, this is x plus h to the 0th power, x plus h to the 1st power. You do not have to write this down. Okay, so looking at this, the first diagonal represents the leading coefficient. Do we notice any similarity? It's always 1, right? Okay. So we are going to start off. If y'all didn't notice that similarity, you didn't need to be in this class.
Oh, okay.
So we've got the limited. A few of y'all just got up. All right. So we've got. Here, let me give a little more room.
Do we have to write that? I think it's up to you.
It should be. All right. So we've got x to the nth power leading off, correct?
Right. Yes.
All right. So the next term, and I'm just going to deal with the leading coefficient first. But y'all let me be the only one talking right now. Thank you. All right. Now, what is the next coefficient in each problem?
N.
Just n, right?
Oh, yes.
1, 2, 3. So it's just n. So I have n times. Now, what happens here? Let's go back to x plus h squared. We have x squared plus 2xh. So you turn a plus into an h. Plus h squared. And then x plus h cubed was x squared plus, no, x cubed plus 3x squared h plus 3xh squared plus h cubed, right?
Mm-hmm.
Okay, so from that, notice what's happening. Each time we move from left to right, we lose an exponent on the x. So this is going to be x to the n minus 1. Are y'all with me?
Yes, sir.
And then it comes up as h to the 1st. Are we okay there?
Yes, sir.
Yes.
All right. So let's move to our next term. I want to try to alternate colors. Can you throw me that blue marker? And we get now this term right here. This is going to be my third term in each column, this diagonal here. So, how do we come up with that third term?
Find a pattern.
We find a pattern. It's going to be n times n minus 1 over 2. So this is going to be 3 times 3 minus 1, which is what?
2.
2 divided by 2 is 3. It's actually 2 factorial. All right. 6 times 5 is, I'm sorry, hold up.
6 times 30.
30.
3, 18.
What?
6 times
Give me a second. Okay, the n is 4 here. N is not 3. N is 4.
Okay.
All right, 4 times 3 is 12 divided by 2 is 6. 5 times 4 is
20.
20 divided by 2 is
10.
6 times 5 is 30 divided by 2 is 15. So we get that third term by saying n times n plus 1, or n minus 1, sorry, over 2 factorial. Okay, then it's going to be x to the n minus 2, right? And then times h squared. Are we still okay? That takes care of this third diagonal. All right, now let's get to the fourth diagonal. The fourth diagonal is n times n minus 1 times n minus 2 over 3 factorial. Okay? So this right here, n is 4. 4 times 3 is 12.
24.
12 times 2 is 24. 24 divided by 3 times 2 times 1 is 6. So 6. 24 divided by 6 is 4. Yeah. All right. Okay, let's get to this term. 5. 5 times 4 is, and 20 times 3 is 60. 60 divided by 6 is 10. All right, 6 times 5 is 30 times 4 is 120. 120 divided by 6 is 20. Okay, so do we see a pattern happening here? All right, so we've got plus n times,
Colors again for the next
yeah,
one?
thank you, I meant to. N times n minus 1 times n minus 2 over 3 factorial times x to the n minus 3 times h to the third plus. Okay, now, what would the next one be? The next one would be n times n minus 1 times n minus 2 times n minus 3, and then it would be divided by 4 factorial. Okay. So, this number right here is what, as far as comparing it with the exponent?
I'm confused. Which exponent?
All right, this is 0. This would be divided by 0 factorial. This would be divided by 1 factorial, 2 factorial. So that would be to the n minus 1 factorial. Is that right? Am I saying that right?
I'm confused.
I don't know.
I don't understand. Don't agree on the weight. I get it. I'm very confused.
All right. I keep going out, and I'm gonna go all the way out until I get to the last, or the next to last term. Well, the next to last term, each one of these values is always in, correct? So I'll just do it with the shortcut. So this is gonna be n factorial. All right? No, not n factorial, just n. Times. All right, what is the next to the last term as far as my exponent is concerned for x?
1.
Mm-mm.
I'm not sure.
Next to the last.
Isn't it not 1?
It's just x to the first. Remember, my next to last term is x to the first.
Oh.
All right? Now, what about my h?
It's n minus 1.
N minus 1, right? So it's times h times h to the n minus 1. And then my last term is finally just h to the n, right? So I just expanded x plus h to the nth power. So this is x plus h to the nth power. And what do we do with x plus h to the nth power?
Divided by h.
Not yet.
Oh, we gotta add the minus x and.
Yeah, we subtract x to the n from it.
At least that makes sense.
And we divide by h.
That's,
Everybody okay with that?
Sure.
All right.
Looks good.
So, what do we always do on this step?
you combine like.
Combine like terms. Okay. Well, what do I have as far as like terms are concerned?
X to the n. and
X to the n, right? I have x to the n minus x to the n. So they go and play with the dodo bird.
That's it.
So, what do we have left here? Well, we have n times x to the n minus 1 times h plus n times n minus 1 over 2 factorial times x to the n minus 2 times h squared plus n times n minus 1 times n minus 2 over 3 factorial.
That's really all we can get rid of.
That was all we could get rid of. You are correct. Okay. Now, what do we do on this step every time we've worked it? I need everybody's attention up here. Y'all, if you got phones out, unless you're recording this, you need to
Divide
Common denominator?
find the common, no.
Oh.
Because we're, that would be, I mean, no, we don't want to do that.
Okay.
You can just divide the h out. Every term has h. in it.
Every term has an h in common, correct?
Yeah.
Factor out.
So let's factor an h out. So what you said was not wrong, but when you watch what I do, you'll see how that would not have helped us any. All right, so we've got h times n times x to the n minus 1, right? We factored that h out. That is horrible handwriting. This is going to be viral, and I'm embarrassing myself. All right, so what happens in the next term?
You get h to the first.
N times n minus 1 over 2 factorial times x to the n minus 2 times h to the first power plus n times n minus 1 times n minus 2 over 3 factorial times x to the n minus 3 times h squared plus dot 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 to the whatever plus n times x times h to the n minus 1 minus 1, right?
Oh, yeah, well, oh, yeah.
So it's n minus 2.
We're on the next last.
Yeah. And then, what is my last one? H to the n minus 1. All over h. Again, h is not equal to 0. H is approaching 0, so it's safe for us to cancel out there. Now we let h be 0 because we will not get 0 over 0. F prime of x is equal to the limit as h approaches 0. Okay, let's start plugging in 0. So we've got n times x to the n minus 1 plus. All right, what is n times n minus 1 over 2 factorial times x to the n minus 2 times 0? 0. All right, what is n times n minus 1 times n minus 2 over 3 factorial times x to the n minus 3 times 0? 0. What is n times
0.
0? Uh-oh, and 0. Uh-oh.
Uh-oh. N times x to the n minus 1.
So the derivative is n times x to the n minus 1. So let's go back to f of x equals n to the 15th power. Well, what is n in this case?
15.
15, right? So I get that f prime of x is equal to
Is that right?
15.
Is that right?
What is what right?
N to the 15th.
It should be x, but.
Well, this would be 0 because n's a constant. It came from my brain, which means it's nothing. Okay. Thank you for catching that. So we get 15 times x to the 14th power.
Wait.
And we got the derivative.
So that's 3 times x squared.
So, and we've already done that once, yeah.
Well, we
F prime of x is
We never got the answer.
3x squared. I mean, we did it earlier in the, not today. All right. So what do y'all think about that?
Easy.
Now, so to answer your question that I deliberately did not directly answer earlier, Annabelle, the lesson today is going to be shortcuts for derivatives. And the first one is the power rule. And the power rule says that if f of x equals x to the nth power, then f prime of x is
N times x to the n minus 1.
That's true for all real numbers?
Let's look. Earlier, we looked at 2 other problems. One of the problems we looked at, and it took us a while to do,
Wait. I suspect people are still taking photos.
Oh, well. Let's hope it's on Google.
It's gonna be on video.
Just yeah, it's okay.
there should not be equals there. Ah.
I think people got their photos.
You don't let me off that easy.
He's going. He's gone. He's fine.
Is anyone taking
I just.
All right. Are we good now? Okay.
We are.
Okay. Y'all don't realize how close y'all were to losing me as a teacher and me becoming a model. So,
This one's going viral.
of course, I was going to be the before model and not the after model. But
Hey, a model nonetheless.
a model nonetheless, and I appreciate your recognizing that. All right. Now, can I erase this?
Yes.
Okay.
Yes.
Now, let's go back for just a second. Look back at where we solved some problems using the limit definition of the derivative. I don't know. Let's go back and look at the example that you have where we did f of x equal to the square root of x.
Okay, that's X. Is this the function?
Wait, hold on. Just slow down, slow down, slow down, slow down. You can write it down, but don't say it. Okay, hold up. I just lost. All right. Okay, so have y'all found that in your notes? Look for it.
Fine.
It should be handwritten notes, not footnotes. You found it. All right. Braden, student of the day. You found it.
What day was it?
What now? But I don't like him.
Numbers
All right.
ready.
So,
What's going on here? So this is a trial and error.
are we okay to keep going?
Yes.
All right. So, what do we know about the square root of x? It is the same thing as
1/2.
x to the 1/2 power.
Oh.
Yes.
So, what is in here?
1/2.
1/2. So let's pull our 1/2 to the front, and we've got x to the 1/2 minus 1, right? And what is 1/2 minus 1? Negative 1/2. And what does a negative exponent mean? We put it in the denominator, right?
Yeah, that's why you Very cool.
And what did we get when we did it in class?
Probably that.
We got that.
Oh, wait.
It took us a little longer, didn't it? But, all right. Am I on your way? Okay. All right, now, let's look at the next one. I think we did something that looked like that.
Actually do.
Y'all try it on your own.
So what is this rule called? It's still a power. But you're just turning it into an exponent.
F prime of x, well, first off, what is f of x really equal to?
X and negative 1.
X and a negative first, correct? Okay.
Correct.
Now, negative 1 times x to the
Negative 2.
negative second, right?
Yes.
Which we get negative 1 over x squared. What did we get when we tried it in class?
That.
Same answer.
That. Again, it took us a little bit longer, right?
Right.
Yeah, probably.
All right. So that is shortcut number 1, and we see that it works for rational numbers. Let's see what else can happen here. Shortcut number 2.
Ooh.
I know it. This is the constant rule. This is a tough one. F of x equals x, no, f of x equals c.
Oh, that's why you said that was.
C is a constant. If I graph the line f of x equals 2, what have I graphed?
A straight line.
All lines are straight.
A
Horizontal line, right? All right. Now, if I have, except for those lines, they're not straight. Okay, so here's my horizontal line, x equals 2, and it has a slope of 0. What if I say f of x? Ooh, y'all don't like fractions, do you?
No.
What if we have f of x equals negative 4, oh, that's even a,
Ooh.
oh, that's a negative fraction. All right,
Second number.
so it's gonna be right here. Exactly. Y equals, that's it. Good grief, y'all let me write stuff wrong. Negative 4/7, right? So,
F of x equals c.
what's its slope?
0.
0, right? So what do we know about the slope of constants?
There's 0.
There's 0.
Yay.
So if f of x is equal to a constant, then f prime of x is
0.
0. Every day. 24/7, 365. Doesn't even take a day off for Christmas.
Does that also mean that if you have an equation like f of x equals like x squared plus minus x squared minus 2, the constant would still be 0 because it cancels out to be negative 2?
Say that again.
If you had an equation that was like f of x equals x squared minus x squared plus 2, I guess. It'd still apply to the constant rule because your x's cancel out.
Well, hold up just a second.
Did you do your essay?
Yeah, f of x now becomes 2.
I'm about to go to Starbucks.
So f prime of x would be 0.
So if you can get your x's to cancel out, then you can use the constant rule.
I think.
If you have a constant left over.
Yay. Okay.
Yeah.
Sure.
But that's no fun.
Baby.
Why would they give you something like that?
Well, presumably it would look more complicated than that.
That is going to lead into the sum and difference. If f of x is equal to g of x plus or minus h of x plus or minus, let's go down to r of x. Then f prime of x is going to be g prime of x plus or minus h prime of x plus or minus all the way down to r prime of x. So let's look at this with, let's mention the problem Annabelle just gave us a second ago. Let's say we have f of x equals x squared plus x squared, no, you said minus x squared, right?
Yeah, sure.
And then plus 2? All right. So we're going to take the derivative of each part individually. So I'm not going to combine my x squares first. I'm going to take the derivative of each part individually. So f prime of x is, okay,
2x.
what is the derivative of x squared?
2x.
2x minus 2x
Plus 2.
plus
Oh, 0.
0. So we get
0.
I hope so, because it's right. What about f of x equals sine of x plus x to the negative 30th? Ooh.
You get
All right, what was the derivative of sine of x?
1. Wait, 1.
Cosine.
It was cosine of x.
Cosine of x. You were coming up with how we solved it out instead of. Are y'all okay?
Yeah.
All right, let's make sure we're paying attention up here. All right, so what comes next?
Minus 1 over.
Minus 30x.
Minus 30 x to the
Negative 31st.
negative 31st. So we get cosine of x minus 30 over x to the 31st. Turn around, turn around, turn around. Y'all, whatever's distracted.
Put you on my top.
Are we able to drink in here as seniors? Or I mean,
No, it's empty. I just
well-
dropped my top.
are we able to bring drinks in here anymore?
Yes.
What do you mean?
Are we gonna be mature enough to handle drinks in here?
Oh, yeah.
Oh, I see,
Okay.
yes.
Thank you. All right. Now, let's go with the next shortcut. Shortcut number 4. There are a total of 7 shortcuts.
7, wow.
And we're going to hit these 4 today. And then we're going to pick up on something else, and then we're going to come back to it later. All right. So f of x is, we get 4 here, right? Shortcut, this is the constant multiplier. And the constant multiplier says that if we have f of x equals a constant times g of x, that f prime of x is equal to the constant times g prime of x. So, example here. Let's say we have f of x equals, I don't know, let's go to 4 times the cosine of x. All right. So, 4 is a constant. So we don't mess with it. So it's negative 4 sine x. It's the constant times the derivative. Again, the derivative of cosine was what?
Negative sign.
Negative sine. So that's what we get there.